Hi, linear algebra students. This is the last section, the last example in the section in planes and hyperplanes. We are dealing with an hyperplane here, so I won't draw it. Passing through this point of our 4, okay, 2, 0, 1, 1, with normal vector 1, 2, 3, 4, okay? And we are asked a bunch of questions. First, we want to find a normal equation, then a vector equation, and then express H as a translated subspace. So there's a lot going on here. It's kind of a recap exercise. So let's answer the questions one after another. Okay, starting with number 1. So first of all, what you have to remember about the normal equation for H is that it is an equation of the form. So normal equation. It is an equation of the form A x1 plus B x2 plus C x3 plus D x4 is equal to, and actually I will change notation here, A1, yeah, I much prefer that, A1, A2, A3, A4, okay, is equal to B, sorry, there you go, okay? So this is the normal equation of a hyperplane. And the normal vector, we have it automatically by looking at the coefficient. It's A1, A2, A3, A4, okay? So, and the value of B is obtained by replacing a point and making the equation true, right? So, B is obtained by replacing a point, saying a point in left-hand side. So in other words, we just have to follow these exact 2 steps, right? So, okay, so since we know that the normal is this, let's actually color code it. Let's color code it in red. So we know for now that we have, okay, so I will just write my canvas here. So for now, we already have that. Okay, so we already know that our equation is going to take this form thanks to our normal vector. And then we're going to take the point, which is right here. I'm going to color code in black this one, I think. Okay, so we're going to take the point that is right here. And what we're going to do is we're going to replace the value of x1, x2. So I'm going to put in bracket x3 and x4 inside this equation, right? So we replace the values of x by the point that we are given. Okay. And of course, as you can see, we're going to get b this way. So what is it? It's 2 plus 3, 5 plus 4, 9. So b is equal to 9. As a result, the equation of our hyperplane, the normal equation, is simply x1 plus 2x2 plus 3x3 plus 4x4 is equal to 9. Okay, so that's the answer to the question number 1. All right, so you can press pause to make sure you copy everything, but I will erase everything except the question itself. Where's my eraser? There it is. All right, question number 2. Find a vector equation for H. So we have the normal equation, Let's actually write it again. So 1x1 plus 2x2 plus 3x3 plus 4x4 is equal to 9. Okay? And what you need to remember is that the parametric vector equation is so we get the parametric vector equation by expressing one of the variables in terms of the others. So by expressing a variable in terms of the others. Okay, so in other words, what we're gonna do here is we're gonna express x1 in terms of x2, x3, and x4. Okay, so we're gonna do x1 is equal to 9 minus 2x2 minus 3x3 minus 4x4. Okay, and now we can make a list. Okay, what we will do is we will set x2 is equal to r, x3 is equal to s, and x4 is equal to t. So these are our free variables. Okay, so what this means is that the vector x, which is x1, x2, x3, x4, okay, and we can already, well, actually, I won't go too fast here, just because I want to make sure that you guys are following me well. So the first thing is to replace RST in the x2, x3, x4. And then what we have for x1 is 9 minus 2s minus 3, whoops, sorry about that, 2r minus 3s minus 4t. So what I did is I replaced these into here. From there, you are doing what you have done in solution set before, right? You split the constants, so 9, 0, 0, 0, plus r times the coefficient, the entries that contain the r. So we have here negative 2, 1, 0, 0, plus s, and as you can see, you're going to get negative 3, 0, 1, 0. And finally, plus t times the vector negative 4, 0, 0, 1. So let's frame that. This is our parametric vector equation. Okay, so parametric vector equation of the hyperplane. All right. Number 3 is very easy. I'm going to erase, but I'm going to keep this. So now we're answering number 3. And then what you need to realize here is that this is your position vector. Okay, so you could also use this one, by the way, because you know that the hyperplane is passing through this point. But let's just write that this is our position vector. And this bit right here, okay, so this is the structure of an element of the span of these 3 vectors, right? So the span of negative 2, 1, 0, 0, like negative 3, 0, 1, 0, and finally negative 4, 0, 0, 1. Okay, so an element of the span will be written like this. So what does it mean? It means that our plane P is equal to the position vector that we have right here, that we will rewrite 9, 0, 0, 0, okay, plus the span of these three vectors. Okay, so the span of like -2, 1, 0, 0, -3, 0, 1, 0, and finally -4, 0, 0, 1. Oh, I said P. I should have said H. There you go. I hope I didn't say P too much. But yeah, I meant H, right? H being the hyperplane. All right, this is it. I hope this helps, and see you either in class or in the next video.